Hello and welcome to this week's lecture. This is going to be Module 12 on Vegetation Analysis and NDVI. My name is Iare and I'm a PhD student under Dr. Mestas Nunez, and I will be taking over lecture this week. Yeah, so like I said, and as we've seen with the module in our calendar, this is going to be Module 12. We're going to talk about using NDVI as a vegetation health index. And yeah, so let's just jump right into it. So here we have the equation for NDVI, which is the near infrared band minus the red band over the near infrared band plus the red band. That may not mean a whole lot to us right now, but we're gonna get real familiar with it as we go along in this lecture. So first things first, we want to introduce how we came across this project that led us to using NDVI. So essentially there was a high pollution day in Austin, Texas, where the air quality was quite low. This day was found by looking at EPA data of ozone and PM 2.5, NO2, and we saw abnormally high values for this day of the year. So we wanted to investigate exactly what might have caused that to be abnormally high. And so this date happened to be October 10th, 2024. And as we investigated more into October 10th, 2024, we found out that in Austin, Texas, there was a brush fire on the east side of Austin, Texas. And so that led us to investigate what exactly might have happened that day. So we're gonna look into a news report regarding this brush fire. So here's some images from the brush fire in East Austin. We see there was a 55-acre brush fire, not too big. I think that's about 0.2 kilometers, so not ginormous compared to other fires that you may have heard of. And 2 firefighters were injured, so you never want to see that, but thankfully no lives were lost. And so as we learn more about this brush fire, you can feel free to click through and look at the video and images. I actually suggest that you do that. I think it's quite interesting when you look into it. So we're gonna look at the location of the brush fire. And so when we're trying to find the location, our first line of defense is going to be the news reports, right? So we're gonna have to see what these news reports are saying about what took place this day. And so based on this news report from CBS Austin, we see that the location was somewhere near the KIPP Academy, KIPP Primary School area in Austin. It seems like a sort of mix between residential and commercial area of Austin. Those who are familiar with the area might know it a bit better than I do. But yeah, so we see they put a pinpoint here about where the fire took place. This is quite, on the corner, on the edge of, one side is commercial or at least we have like roadways and concrete slabs where they have businesses and things like that. The other side we have vegetation. And so obviously the fire isn't really happening if it's a brush fire, right, it's not going to be happening in places where we have, pavement and roads. And so this makes me sort of question, okay, did the fire actually occur here? And so as we research even more, and so we look into, this is widely reported, there's probably quite a few articles that go over this. So we look into this a bit more, and we go into another article from KXAN, and we'll see where do they say that this fire took place. So looking at their map, they have it on not only the other side of the road, but quite a bit of a ways down the other side of the road. We're looking at, the other one had it here next to this 969 sign, and over here we have it on a completely different side of the road. So which one is it? And this kind of shows sort of how some of the news reports can be a little bit unreliable as far as the accuracy that is needed as scientists and engineers in order to look into these sort of things and find out exactly what sort of impact that was made on the vegetation. So this isn't going to be enough, right? So we're looking at the different pinpoints they gave us, and it's not enough because was it here? Was it here? Where did it start? Did it spread here? So let's back up and see what we can find out about where exactly this fire took place and what we can learn about the fire's impact on the vegetation. And so a bit of a note about NDVI. I think this is something that it's very useful. Not only is it useful in looking at fires, but I think a lot of most of the use for NDVI comes in looking at vegetation health. So that's people who are interested in agriculture or ecosystem, environmental conservation and preservation. And so when you look at NDVI, I've used it personally in my quite frequently because we needed to understand the vegetation phenology, or rather the seasonal activity in the vegetation, so that we can understand what places are more at risk when it comes to fire danger and where the fire might spread based on the condition of the vegetation. So it's important. This is an important tool for you to learn if you're interested in going to those spaces and working as a scientist and engineer. This is sort of NDVI is sort of like a gateway index, if you will, to other indices and other analysis in science. So this is going to be a good introductory index for us to focus on today. And so in using any index, we need to establish a few things. We need to know when the event that we're looking for happened. So we have that established. That's going to be October 10th. We need to know where it happened. We sort of have that established. We have a general idea of the location in which it happened. We don't know exactly. We know it happened in East Austin, around the KIPP Academy green space area. So we have sort of a where, and we need to know what. What are we looking at? Are we looking at land for vegetation? Are we looking at air to look for smoke or air pollution? Are we looking at sea? Are we trying to find sea surface temperature or look at chlorophyll or salinity? So we need to narrow those type of things down. And so obviously, since we're looking at land here, or we're looking at vegetation here, we're going to be focusing on land. And so with that information in place, we can now take that into acquiring the data that is needed for this sort of study. And so so the first thing we're going to do in looking for the data is we're going to head over to the USGS Earth Explorer interface. All right, so we're here in USGS Earth Explorer. We're going to add a few fields and a few parameters to help us narrow down our data. So the first thing we want to do to narrow down our data is to narrow down our region of interest. So we're going to zoom into Austin, Texas here. All right. Here. So now we've got Austin, Texas pulled up. We know it's going to be East Austin, the general region. And many of these satellites take pretty big swaths, so we don't need to be exact on our perimeter. But we're going to also establish a perimeter that we want the satellite data to at least include that, right? So right now it's got a pretty big one. I'm going to make a new one. So we're going to use the map here. Oops. Okay. So we know it's in the East Austin region. So we're just going to sort of click arbitrarily. Let's put one here, one here, one here, and one here. So we know any satellite data we pull is going to include this area. So let's move down. So we know that the date of the fire was on October 10th. So October 10th. And so this is important to know because we want to not only get the NDVI, but we want to also calculate the difference in NDVI so that we can pinpoint exactly where this fire took place. So in order to do that, we're going to need pre-fire images and post-fire images. And so we're not just going to click on October 10th here. We're going to need to choose a date that was before and also after. So what we'll do is go to October 10th or October 2024. And we know that we're going to be using Landsat for the data set here. And so it's important to keep in mind that Landsat has, I believe, a resolution of about 14 to 16 days or something like that. So we know that the likelihood of, it falling on just the day before or maybe even the same day but early in the morning on October 10th is very unlikely. So we should expand our range a bit, and we can adjust as we go if we need to. So we're going to pick on October 1st, 2024 for our date, for our pre-fire date rather. And we're also going to pick our post-fire date, and we'll need to schedule that a bit out. Give it a little bit of slack to catch an image in case there's, a cloudy day or something of that nature. So October 10th, let's give it about a 1 month buffer. Let's just go into November 10th. Okay. So now we've selected our date range. We're now going to select our cloud cover. So we want to pick days that are not cloudy. So we want the cloud cover range to be, we're going to keep it pretty low. Let's keep it around 10%. So now we've got that set up. We can click on data sets and begin to look at our data sets that are fitting of this criteria. So we see Landsat here. We're going to click on Landsat, and we want the most up-to-date Landsat. So let's find the most up-to-date Landsat data here. So let's go to collection 2. We're not going to get into collection 3 because we're talking about science products that we're not going to get into. We're just trying to get the land cover. So let's go to collection 2, level 2, and take the OLI and tiers data set. So let's head over to results and see what this came up with. Okay, great. This sort of worked out perfectly based on the range that we chose. We have one date that is before the day, and the way we're seeing this date here is 2024, 10 for October, and then 8. So that's before the 10th. That'll work just fine. And then we have a date that was after the fire, but it goes out to November 9th. November 9th, 2024. So thankfully we set our date range out to November 10th. Just sort of squeezed in there because we didn't have any good images between October 10th and November 10th until we got to November 9th. So that just goes to show that there were about maybe 2 images that were taken that were just not of good enough quality for the study that we're doing here. So great. So we have this data here, and once you're signed in, you can start to download that data. And like I said, with the area, it wasn't too important where I put it. I could have put it over all of Austin if I wanted to. Because it was just going to include that. This is how big that footprint is on these regions. So we didn't have to be too specific. We just needed to get the general area. But great that we were able to get this data. Alrighty. Right. So now that we've got our data downloaded, we want to narrow down exactly where this fire might have taken place. So here we are in ArcGIS Pro. I'm going to show you where the reported locations were for the fire that we saw in the news reports earlier. We have one for CBS Austin and one for KAXN. We can see that there, the distance between them, right? And so we know that this fire occurred somewhere in this region. We know that it was a brush fire, so we're going to be narrowing down to places that have brush. So that's not going to be this human occupied area over here, residential or commercial area here. We're going to be focusing on where there's brush. So we're going to be looking at the green spaces up here, green spaces down here. And so the general sort of area that we're going to hone in on is something of the mindset of I'm just using this measure tool for an example. This isn't actually going to help us do a whole lot here. I'm just using this measure tool for an example. We have it somewhere around here. This is what we're looking at here. You may not be able to see it. It might be kind of faint on your screen, but if you look closely, you'll see a rectangular shape that we've cut out here. And that's the area that we're going to be clipping for this study here. So the clipping's already been done. It's only a geoprocessing tool that you can use to extract by mask for the data once you have it in a GIS, or you can also do that in Python. I'll be working on making a Landsat data collection through API in Python eventually. And so that way it'll streamline sort of this work in the future. But for this, I sort of did it the quick and dirty way, which is going into the ArcGIS Pro and using the GUI. But yeah, so eventually we'll have that streamlined. But for today, I'm going to show you the nuts and bolts of how it's actually done. And I think it's good to also know how it's done, the sort of the manual way, before jumping into the Python notebook and just clicking Shift Enter a bunch of times and having it do it for you. So it's good to sort of understand the nuts and bolts behind it. But I digress. So we go into talking about back into NDVI, right? So this is the NDVI equation, just like we talked about earlier in this lecture. We have or NDVI, which is Normalized Difference in Vegetation Index. We have near infrared band minus the red band over the near infrared band plus the red band. So what exactly are these band numbers? Because that's going to be important when we go into looking at it in a Python context. So going into the Landsat 9's operational land imager, the band numbers for near infrared and the red band are going to be 5 and 4 respectively. And so we see the ranges for the wavelengths for those bands, as well as the spatial resolution of 30 meters, which is pretty good for what we're looking at. It's adequate to do what we're trying to do today. So this will be just fine. Now we've got established that the red band is band 4, near infrared band is band 5. Let's go ahead and jump into our Jupyter notebook. So this version of the Jupyter notebook is my version. It's going to look very it's going to look very similar to yours. The main difference is I'm just going to have my paths entered in here. Once you have your data downloaded from Canvas, you're going to enter your paths. But here we're going to be working in my folder that's already got my specific paths laid out, but everything else is going to be the same. So first things first, we want to do our imports and installs. If you don't have any of these installed already in your Jupyter notebook, let's go ahead and uncomment these out by removing the hashtags or the pound signs and running those installs. If you don't know if it's installed or not, just run it the way it is, and you'll get an error spit out saying which one of these isn't installed. So whichever one isn't installed, you can click on, you can uncomment it out and install it here. So once this is run, you'll have all the packages you'll need for this notebook, and you'll be good to go. Next, this is the code block that's going to be doing some of the heavy lifting for this lecture. All you have to do is enter your specific paths. So all that's going to be doing is changing everything up to here. Everything else should be, everything after that, the clipped NIR pre-post should be the same. And so we're doing this twice because we have two images, right? So we need the red and near infrared bands for pre-fire and post-fire. So that's why we're doing it twice here. So once those are established and we have those images saved into their respective variable names, let's go ahead and run that code very quick. We're going to create the functions that are going to calculate the NDVI. And so that's going to be just this equation that we are familiar with now. And it's going to be put in, it's going to look like this when it's not laid out like that. It's going to be like this in line. So all we're doing here is band mathematics or raster mathematics. And so we're doing this twice for the pre-fire and the post-fire. And each of these equations is going to have the near infrared and the red band here. And then also in these definitions, we're going to be plotting, in these function definitions, we're going to be plotting the data as well. So let's go ahead and run this code, the quick Shift Enter. All right, when you run the code, nothing's going to show because all we're doing is establishing the definitions here. The next few lines is where we're going to actually see some output because now we're running these functions that we have just created. So let's execute the function for the pre-fire NDVI that we just created. And you get this runtime warning. You can go ahead and ignore that. Okay, so we have NDVI before the fire. Nothing super remarkable here. It's primarily you can see the vegetation is quite neutral. It's hanging around zero. Not exactly, just dead vegetation everywhere, but it's definitely not super healthy or super lively. I guess that's just what we're getting around this time of year in this region in Austin, Texas. So once we're done with that, let's go ahead and look at the post-fire image. And it's quite the same about a month later. Not too different. Maybe it's a little bit lighter. Vegetation's a little bit healthier. But we're pretty squarely in fall at this point, so it might be a bit cool. Maybe not as hot. However, vegetation is dying off. Not too much to glean from here. Not too many details to pull from this. But, we are starting to see a little bit of something that wasn't really there before. We just kind of see this little white spot here. Okay, that's something interesting that might have to do with what we're looking at. But the difference between the images isn't quite obvious at first sight. And so that's where we need to run the difference in NDVI. So when we run the difference, we can actually see what changed between the pre-fire image and the post-fire image. So let's go ahead and run that and see what we come up with. All right, so now it's quite clear that we have a suspected area of where this fire might have occurred within this clipped region. So we're looking at it here, and we see this circular area of significantly lower NDVI. So the vegetation here is significantly less healthy than the vegetation surrounding it. It's also important to keep in mind that not everything up here is vegetation. Like we saw before, we do have some regions where there is, paved roads and industrial things going on here. So, but like we said, we've seen an area here. So what is that? That could be, for all we know, that could be a parking lot. That could be, the burned area we're looking for. That could be crop circles. Who knows what it is, right? So that's where we're going to jump into. We're going to jump back into our ArcGIS Pro and take a deeper look into what we see here. Go ahead and clear that out. All right. So now we've got established the clipped region and the difference in NDVI. And we've plotted that against a base map of the satellite imagery. We can see that this region of suspected wildfire or brush fire activity is pretty squarely in a vegetated area. It almost looks like some farmland, right? Maybe some short grass, or as the article says, some brush, right? So let's zoom in here. As we get some more details, we can see that this is definitely some sectored off area. You can see we have a line of trees here that are showing on the satellite imagery. Let's run it here. We'll just flip on and off for a second. And I think, that matches up quite well. So I think we can say with confidence that this is where that East Austin brush fire took place. So you can even see towards the edge of this. Let's do some symbology. Maybe I can make this transparent so that we can compare a bit easier. So let's increase the transparency. Let's take it to, 40% should be good. We've increased the transparency, so now we can sort of see behind it a bit. Right, so what are we seeing here? We have these area where the vegetation was a bit more unhealthy than others. So we've got this sort of orange region that kind of goes to yellowish around this tree line on both sides here. And so what we're seeing here is maybe a thicker line of vegetation around. And that's pretty consistent with what we've seen. And so we can see that in this particular region that's showing a bunch of red pixels here. So this is showing that the vegetation is much less healthy than the surrounding area. And so this particular region might be where the fire might have started, right? So the fire was said to have been started by some machinery malfunction that took place. So that might be some sort of farming equipment or a car or we don't know out here, right? But we know the fire started somewhere. And if you had a list of places to rank a list of places of where this fire might have started, I'd probably start with having this a number one on the list, since this is where the most unhealthy vegetation is. So I'm assuming that this is where the vegetation changed the most, and where the burning was maybe the hottest or burned the longest. And so this is we can almost pin down exactly where this started if that's the what we find here. And so this is important to know, right? Because the news articles, they only give us so much. We can see that CBS Austin and KAXN, they were quite a bit off when it came to pinning down exactly where that fire took place. This might have been the location where the fire personnel were told to maybe park their cars or park their engines and their vehicles before they got to where the fire was actually taking place. But let's be a little petty here and a bit curious exactly how far off they were. So they were about 1,000 meters off when it came to it. When it came down to it. That's, it's not too far off. I believe if you're within 1,000 meters of the burn site, I'm sure you can see the smoke in the air, as we saw in the images in the videos from the news articles. We could see that the smoke was quite clear in the atmosphere. And in our studies, we found that the smoke was even visible from downtown Austin area. As we saw from our colleagues at St. Edward's University, they saw the smog cloud coming from that direction. So the smoke should be quite visible. But if we're scientists looking for the exact location, that news report's not going to be enough, because the two sources that they gave us were considerably off from a scientific standpoint as far as finding the pinpoint location. And that's important, because when we do models for wind trajectory or models for tracking the smoke plume, we need to know exactly where the fire took place, exactly where this fire started. And so context clues and news report locations aren't going to be enough. So it's great that we're actually able to do this research and do the Python coding to run the difference in NDVI to find exactly where this fire might have taken place. Now, NDVI is not the only index that could be used to track fire. There are a few others, some better than others, depending on what you're looking for. I won't spill the beans here, because that's one of the questions on the module exercise. But there are some better ways to quantify the amount of damage that was done to the vegetation here. But NDVI is definitely a great one. NDVI is almost sort of a gateway index in a way to a bunch of other indices, whether you're looking at fire or soil moisture, vegetation health, fire intensity, things like that. There are a number of indices that can do these type of scientific analysis. But NDVI is sort of a good gateway, one that can get you started and get the ball rolling. It's got a pretty simple equation. Near infrared and red bands are available on nearly every land imaging satellite out there. So it's a great one to look at. And like I said, I've used it in the past in my internships and things like that. So this sort of experience is great when doing your research, and a great add to your resume as well. And so that's going to be the conclusion of this lecture. I hope you all enjoyed it and were able to learn something about NDVI and Python coding. I'll be looking forward to any questions that you may have. Feel free to reach out to me via email or through Canvas. So I hope you all have a great week and rest of your semester, and happy Python remote sensing.